Okay, next theorem from pair of straight lines. The theorem statement is like this: if the equation h is equal to ax square plus 2hxy plus by square is equal to 0 represents a pair of intersecting lines. The combined equation of pair of bisectors of angle between these lines is h into x square minus y square is equal to a minus b into xy. Okay, so this is the theorem. Simply this equation is called, it is the combined equation of angular bisectors of the straight lines represented by h is equal to 0. Okay, so it is the combined equation of angular bisectors of the straight lines represented by h is equal to 0. So that is we have to prove in this theorem. So let us see proof. Since h is equal to 0, h means here ax square plus 2hxy plus by square is equal to 0. So it is a second degree homogeneous equation. Homogeneous means all the terms have equal degree. Here x power is 2, xy means x power 1, y power 1. So total degree is 2, and y square, that means the power of this variable is also 2. So all the terms have equal degree, so that this is called homogeneous second degree equation. So this equation represents a pair of intersecting lines that is given and they are passing through origin. Okay, since it is homogeneous second degree equation, the equations represented by this are passing through origin. That is we have to understood here. h is equal to 0 represents the pair of lines, pair of straight lines which are passing through origin. Which are passing through origin. So this is the main point here. Since it is a second degree homogeneous equation, that's why this equation, this second degree equation represents a pair of straight lines which are passing through origin, and those lines can be taken as they are y is equal to m1x. This is let us say this is equation number 1 and this is equation number 2, and the second straight line is y is equal to m2x. Okay, let us say this is equation 3. So generally a straight line passing through origin means the general form is y is equal to mx. Here two straight lines are represented by this, so we can take like this: y is equal to m1x and y is equal to m2x, where m1 is equal to tan theta 1. That means it is the angle made by the straight line with the positive direction of x-axis in anti-clockwise direction. Similarly, m2 is equal to tan theta 2. Okay, so let us see continuation. Okay, let us draw one rough diagram like this. X-axis, y-axis, so this is the straight line y is equal to m1x This is another straight line y is equal to m2x. Let us say this straight line makes an angle with the positive direction of x-axis in anti-clockwise direction. Let us say it is theta 1, and the second straight line makes an angle theta 2. Okay, and this is the angle between these two straight lines, and we have to find the combined equation of angular bisectors which bisect these angles. Okay, so let us say this is the angular bisector. This is another straight line which is passing through origin. So this can be taken as y is equal to mx. Okay, so this straight line represents the angular bisector of y is equal to m1x and y is equal to m2x. Okay, let us say this straight line makes an angle with the positive direction of x-axis in the anti-clockwise direction as theta. Okay, this can be taken as theta. Then these two angles can be represented by like this. Here theta 2 is greater than theta is greater than theta 1. So among these three angles, theta 2 is the largest angle. So theta 2 is greater than theta and theta is greater than theta 1. So this angle between these two lines is represented by theta 2 minus theta, and this one is represented by theta minus theta 1. Okay, these two are equal because this is the angle between the pair of straight lines. This angle is bisected by this straight line y is equal to mx. That's why it is called angular bisector. Okay, so that is the main point here. So let us see. So equation 1, that means h is equal to 0. Equation 1 can be represented as ax square plus 2hxy plus by square is equal to m1x minus y into m2x minus y. Okay, since these are the straight lines represented by this second degree homogeneous equation, we have to multiply these two and then compare with the different various force of x and y. We get the values of a, 2h, b. Okay, let us see the multiplication. m1x into m2x, m1 m2 x square, m1x into minus y, minus m1 xy, next minus y into m2x, minus m2 xy, minus y into minus y, plus y square. Continuation, m1 m2 x square, take minus xy as common in these two terms, then we get minus of m1 plus m2 of xy plus y square is there. Okay, now comparing these two equations, we get the values of a, 2h, b. Here a means it is the coefficient of x square on left side. So a is equal to, comparing, a is equal to m1 m2, 2h which is the coefficient of xy on left side, and on right side it is minus of m1 plus m2, comma, coefficient of y square is b on left side, and on right side here only one y square is there, so it is equal to 1. Okay, now these are the values of a is equal to m1 m2 or m1 m2 is equal to a. Here m1 plus m2, that means minus 2h, just transposing minus to left side, and b is equal to 1 or 1 is equal to b. Okay, next we take the angular bisector. Let y is equal to mx be the angular bisector. angular bisector of these two straight lines. Okay, angular bisector of equations 2 and equation 3, where m is equal to tan theta. Okay, so this straight line makes an angle theta 1 with the positive direction of x-axis, and this second straight line makes an angle theta 2 with the positive direction of x-axis and anti-clockwise, and this is the angular bisector of these two straight lines, which makes an angle theta with the positive direction of x-axis. Okay, so that's why we take m is equal to tan theta. So from this diagram, so these are the angles, these two angles are equal. Okay, because this is the straight line which bisects the angle between these two straight lines. Okay, so these two are the angles represented by the trapeziums. So from the diagram, theta 2 minus theta is equal to theta minus theta 1, transposing minus theta 1 to left side and minus theta to right side, then it becomes theta 1 plus theta 2 is equal to 2 theta. Minus theta goes to right side, it becomes 2 theta. Okay, now we have to apply tan on both sides, then we get the final result. Let us see that. Continuation. So apply tan on both sides. Tan theta 1 plus theta 2 is equal to tan 2 theta. Okay, let us say this is A and this is B. Then we have the formula like this: tan A plus B, that means tan A, that means tan theta 1, plus tan B means tan theta 2, by 1 minus tan A means theta 1, into tan B, that means tan theta 2. Here tan 2 theta means we have the formula like this: so 2 tan theta by 1 minus tan square theta. Okay, now we have to substitute the values. So tan theta 1 means it is nothing but m1 tan theta 2 m2 by 1 minus tan theta 1 m1 tan theta 2 m2 is equal to 2 into tan theta means m by 1 minus tan square theta means m square. Okay, since we know that m is equal to tan theta, m1 means tan theta 1, m2 means tan theta 2. Okay, these are already known. Now substitute the values of m1 plus m2. m1 plus m2 means minus 2h by 1 minus m1 m2 means A, sorry, 1 means B. Remember this, m1 plus m2 means minus 2h, 1 means it is the coefficient of I square on right side, and on left side it is equal to B, and m1 m2 means A. So 2 into m, what is the value of m? Since we have the angular bisector like this, y is equal to mx, from this m is equal to y by x. Okay, so m means y by x whole by 1 minus m square means y square by x square. Okay, so multiply the denominator with this minus, cancel the 2 on both sides, h by, multiply the denominator with this minus, we get a minus b, minus into b minus b, minus into minus a plus a, h by a minus b, and on right side y by x, take LCM here, x square into 1, x square minus y square by x square, 1 x is cancelled. Okay, and the remaining x goes to numerator. It become like this: xy by x square minus y square. Okay. Now taking cross multiplication for these equations, we get h into x square minus y square is equal to a minus b into xy. That implies taking cross multiplication, we get h into x square minus y square is equal to a minus b into xy. Okay. So that is the proof. Thank you.